Hey guys, Danielle Gillham here, teaching you about Module 1, Algebraic Reasoning, Graphing, and Connections with Geometry. Alright, so a graph to correlate with the function of the amount of gas in a gas tank when a driver refills the tank on a drive across country. So this point right here is when he starts driving, and as you can see, the line goes down because he's driving. And then this may or may not be when his tank is empty, or maybe he just decides to fill up at this time. So he stopped at this point, and as you can see, it's just gradually filling up. And then that's most likely where he filled up his tank. But of course you don't know because there's not that much information for it. So then that's when he's done filling up and he starts driving across the country again. And that's how we tell that one. Here's a graph to correlate with the function of the height of an elevator stopping at each floor on the way up. So right here, he's getting into the elevator, and then they're at a rest to go to the next floor, and then he stopped at another floor, and another, and so on. So as you can see, it's just like going upstairs, but instead he's stopping at each floor. Here we have a graph to correlate with the function of the height of a bouncing ball dropped from a table. So this one I'm going to draw for y'all. Sorry about my drawings. So let's say this is a table right here, him standing on it, and he bounces it down, and it bounces back up, but it doesn't bounce all the way up, and it just keeps going like that until it finally comes to a rest. Here we have a graph to correlate with the function of the length of a shadow of a flagpole, length of a shadow of a flagpole throughout a sunny day. So this one kind of looked weird, but if you look at it, the shade is at its longest in the morning, right here. So this is the length of the shadow on this axis. And this axis is the time of the day. So we're going to say this is morning right here. The length of the shadow is at its highest point. And then as the sun is hitting the horizon, the shadow just starts to go down. And then when the sun starts to go back down, shadow goes up. And that's how we do that one. All right, so don't let this graph and chart fool you. It kind of looks a little complicated, but suppose we have two function machines. They're hooked up in a sequence. So the output chute of machine G empties into the input hopper of machine F. Such a coupling of machines, which is defined if the range of G is a subset of the domain of F. So here's F of X. Such coupling, here we go. The domain of F is called of the composition of F and G can be written F of X equals F of G of X. Suppose F is tripling. So we're going to say it's tripling. So here's our given sets of X, and it's 0, 1, 2, and 3 is what we were given. And now we're trying to triple them. So if we triple 0 times 3, we're going to get 0 still. 1 times 3 is 3. 2 times 3 is 6. And 3 times 3 is 9. So that's how we got 3 of X. 3 times X, sorry. Now we have G of F of X, which equals f of x plus 8. But that's because we're now adding 8 machines are coupled in reverse order. So now from the 3 vets, we're now adding 8 from that. So we have 0 plus 8 equals 8, our final answer there. 3 plus 8, 11. 6 plus 8, 14. And 9 plus 8 is 17. And so here we are. The blue line on this graph is 3 of it, and the points are all marked here. And the orange line is f of x plus 8 after the blue line. So here's our points here. So we're going to check a point. 1, if x is at 1, right here, 3 times x, it's now going to be at 3 on the 1. That's how you check it. So here we have show and explain the slopes of the line segments determined by the given pairs of points. In each case, tell whether the set segment is vertical, horizontal, slopes upward to the right, or slopes downward to the right. So this slope is up off the line and to the right. And our given formula for equations such as this is y2 minus y1 over x2 minus x1 equals m. And m is simply just the letter for slope. So let's figure this out. We have, let me move this. We have points 3, 1 and points 5, 5. And this is x1 and x2, or y2, y1, sorry. x2 and y2. So now we're going to do the formula, y2 minus y1, which is 5 minus 1, over 5 minus 3, which is x2 minus x1, equals m, the slope, and we're going to get 4 over 2, and 4 over 2 equals 2. So the slope is 2. And to double check it, off this point right here is 1, 2, 3, 4 points up, and from the point over here to here is 1, 2 points over. And then we'll do 4 over 2 just to double check our math, and you get 2. So here we have show and explain the slopes of the line segments determined by the given pairs of points once again. And we are given 5, 8 and 5, negative 8. Let's go ahead and write those. And that is x1, y1, x2, y2. Let's go ahead and fill it out. Negative 8 minus 8, which is plus 8. And then 5 minus 5. So we're going to get sorry, that part's wrong. That's just a minus. So we're going to get negative 16 over 0. And because the bottom denominator is a 0, this, anytime you have a denominator for a 0, when you do this kind of math, this is called a undefined slope. Exactly why it's just a straight line right here, because there's no slope. And 5, 8 is our point right here, and 5, negative 8 is our point right here, just as it shows. Okay, so we have these points, and here's it graphed So once again, y2, sorry guys, y2 minus y1 over x2 minus x1 equals m, the slope. So we have negative 13 minus negative 4, which is plus, and then negative 4 minus negative 1, which is a plus. So now we have negative 9 over negative 3, and we have a negative over negative, so it's going to turn into a positive, and that's going to be 3. So 3 is our slope. And as you can see over here, we have our 9 and our 3, so that just double checks that. And it's going downhill, so that's why there's negatives. All right, so we are given these parabolas. We have x squared plus 7, x squared, and x squared minus 7. So x squared is just a simple regular parabola, the main example one. And then for the plus 7, you're simply just going to move it up axis 7 points. And then this one, minus 7, is going to be down the axis 7 points. I'm going to show you them all together. So of course they're color coded. We have x squared is the red, just like it was shown. X squared minus 7 is the green, down 7. And x squared plus 7, up 7. So now we have explain the equation of a line through the given point that is perpendicular to the given line. The slope of the perpendicular line is the negative reciprocal of the slope of the given line if the given line is neither vertical nor horizontal. So if you plug in all this and graph it, let me move my little thing. Our new slope is 4 over 3 times x minus 9 right here. This is our new slope. And negative, this right here is where they meet. And this simply right here, if you put in all the points correctly, which we did, as you can see, these are 90-degree angles, and 90-degree angles from two lines are perpendicular lines. So right here we have, if you change this, it turns into y equals, well, this equation right here, the red one. And if you look at these are simply another set of perpendicular lines. And now m over 2/9, m equals 2/9. This is our new slope. This one's quite interesting. So we have a circle, a radius of 9, here's our center, which is our origin, and our slope is 0 because we have a circle, and we have y minus negative 9 equals 0 times x minus 0, which is y equals 0x plus 9, which makes y equals 9 right here. And if we were to find these points, we have these points, and these points, and this one are all located over here. All right, guys, and I just wanted to show you all this one, you know, without all the words on it, and to make it a little more simple. Again, here's our center. Here's the points on there. Don't forget our radius is 9, and our diameter is 18. All right, guys, thank you for learning with me so much.